All right, let's break down one of those classic coding problems that interviewers absolutely love to ask. We're going to pull it apart, piece by piece, find the most elegant solution, and really get to the bottom of why it works so well.
So, picture this. You're in the interview hot seat, and they give you a puzzle. You've got two lists of numbers, all jumbled up. Your job? Pair them up, multiply each pair, and then add all those results together. But here's the catch. You have to make that final sum as tiny as possible.
You know, theory is great, but to really wrap our heads around this, we need to get our hands dirty. So let's walk through this whole pairing puzzle with some actual numbers and see what we're really up against.
Okay, so here are our two lists. We've got array 1 with 6, 1, 9, 5, and 4. And then array 2 has 3, 4, 8, 2, and 4. This is our starting point, just a random, totally unsorted jumble of numbers.
You know, the first instinct is often the simplest one, so let's go with that. What happens if we don't use any strategy at all and just multiply the numbers exactly as they're lined up right now?
Let's run the numbers. We pair 6 with 3, that's 18. Easy enough. Then 1 with 4, which is just 4. Now hold on. 9 times 8, that gives us a whopping 72. Oof. Okay, moving on. 5 times 2 is 10, and 4 times 4 is 16.
Okay, let's add all those products up. 18 plus 4 plus that big 72 and the rest, and we land on a grand total of 120. So that's our baseline. It's the number to beat.
120. It just feels kind of high, doesn't it? That 72 we got from multiplying the two biggest numbers, 9 and 8, is a huge red flag. It really makes you think, is this the best we can do? Or is there a much smarter way to pair these things up?
And you guessed it, there is absolutely a smarter way. It taps into a really powerful idea from computer science that helps us make the best choices, one step at a time.
It's all about something called a greedy algorithm. Now that might sound complicated, but the idea is actually super simple. At every single step of the problem, you just make the choice that seems best right now, without worrying about what happens later. And the hope is that all these little best right now choices will lead you to the best overall result in the end.
So for our problem, what's that best right now choice? Well, if we want to keep the total sum small, we have to avoid creating giant products along the way. And what's the fastest way to get a giant product? By multiplying a big number by another big number. So our greedy strategy should be to stop that from happening at all costs.
And that one simple idea leads us straight to the solution. This is that aha moment that cracks the whole puzzle wide open. It's a beautifully simple rule I like to call the smallest meets largest rule. Let's see how it works.
The rule is just two simple steps. First, you take one array and sort it from smallest to largest. Then, you take the second array and you sort it the exact opposite way, from largest down to smallest. That's it. Seriously, that's the whole strategy. Now, check out what happens when we do that. Our first array becomes 1, 4, 5, 6, 9. The second one is now 8, 4, 4, 3, 2. Look at those pairings. The smallest number from the first list, 1, is now lined up with the largest from the second, 8. And on the other end, our biggest number, 9, is now paired with the smallest, 2. See what we did there?
So let's run the numbers on this new setup. 1 times 8 is just 8. 4 times 4 is 16. 5 times 4, that's 20. 6 times 3 gives us 18. And 9 times 2 is also 18. Just look at those products. Not a single one is even close to that crazy 72 we saw before.
And now for the big reveal. When we add all these smaller products up, we get a new total of just 80. That's a huge difference. We went all the way from 120 down to 80 just by being smart about how we paired the numbers. And that, right there, is our minimum possible sum.
Okay, so understanding the logic is half the battle. But you know, in an interview, you gotta bring it home. The other half is turning that awesome logic into some clean, efficient code. So let's take a look at how you'd actually do that.
So in Java, for example, how you code it depends a little on your data structure. If you got a list, it's super easy. You sort one normally, and then you just use the built-in reverse order helper for the other. Done. If you're using a basic int array, no problem. You'd sort both normally, then just write a tiny loop to reverse the second one yourself. Either way, the core strategy is exactly the same.
And a quick but super important note on efficiency. How fast is this thing? Well, multiplying the pairs one by one is pretty quick. That's what we call O of n. But the real workhorse here is the sorting. A standard sort takes O of n log n time. And since sorting is the slowest part of our process, that's what sets the overall speed for our entire solution.
All right, let's wrap this all up. When you get this question in an interview, what are the absolute key points you need to hit to show them you've completely nailed this problem? First, you state the strategy loud and clear. You sort one array ascending and the other descending. Second, you can add a bonus point. Mention that this logic is super robust. It even works perfectly if you throw negative numbers into the mix. And third, here's a pro tip. Point out that if the numbers could be huge, their products might overflow a normal integer, so it's much safer to use a long to store the final sum. That shows you're thinking about edge cases.
And remember, interviewers aren't asking this stuff just to see if you can solve a puzzle. They're testing your problem-solving process. Can you see the problem, identify the core principle, like a greedy algorithm, and then use it to build a solution that's not just correct, but also elegant and efficient?
And don't for a second think this is just some random textbook exercise. This exact problem, or a tiny variation of it, is a favorite at some of the biggest names in the business. We're talking Amazon, Accenture, Infosys. These are companies that hire thousands of developers. Being ready for this one is a big deal.
So, I'll leave you with one final thought to chew on. You now know the perfect strategy to find the minimum sum. But what if the interviewer flips the script on you? What if they ask you to find the maximum possible sum instead? How would you tweak the strategy we just learned? Give it some thought. The answer is just as clever.